Okay, this is going to be day 2 for section 1-2, and we're looking for tests for symmetry. And so the first thing we're going to do is talk about the different types of symmetry. Okay, the first one is symmetric to the x-axis. It is symmetric to the x-axis. IFF is if and only if every point x comma y has a corresponding point at x comma negative y. So if we're looking at our x-axis, that means we have a graph that looks the same above the axis as it does below, and we have a point at x comma y that corresponds to a point at x comma negative y. Okay, or basically you can flip it over the x-axis. The second symmetric is to the y-axis. Symmetric to the y-axis if and only if every point x comma y has a point negative x comma y. So in this case, we have a graph that mirrors along the y-axis. So every point x comma y has a corresponding point at negative x comma y. Okay? Or we can fold it over the y-axis. The third is symmetric to the origin. If and only if every x comma y has a negative x comma negative y. And so if we look at a graph, basically looks something like this, where we have x, y, and we have an equivalent point, negative x, negative y. Okay, I always think about these as their spin. So if we can spin the paper 180 and look at it, it looks just like it did before. Okay, that's a symmetric to the origin. Symmetric to the y means we can fold it across the y like a pancake or like a hamburger bun, and on the x we can fold it and it creates the same pattern on both sides. Okay? The importance of this comes when we are looking at what kind of functions they are. So we have even functions are symmetric to the y-axis. odd functions are symmetric to the x-axis, okay? And if they're not symmetric to the x or the y, they're neither an odd or an even function. So we're going to look at 3 of them, and you're going to need to get out Desmos, or pull up Desmos on your calculator or phone or computer to look at the shape of these functions. Okay? Graph on your calculator. Or Desmos. And tell whether the function is even, odd, or neither. Law of when the light turns itself off. Okay, there we go. Graph on your calculator or Desmos and tell whether the function is even, odd, or neither. Let's look at number 1. So if we have f of x is equal to x cubed minus 2x. Okay, pull that up on your graphing calculator and we are going to get a graph that looks like this. You'll have to forgive my sketching. And okay. So, if it's symmetric to the x-axis or the y-axis, and in this case, this function does not appear to be symmetric to either of them. Okay? So it's symmetric to the origin. Oops, and I screwed up something. So hopefully I can go back. But I screwed up because I'm copying and I didn't read it correctly. Odd functions are symmetric to the origin. So this is symmetric to the origin, so this is an odd function. Sorry about that. Number 2, we look at g of x equals x to the 4th plus 2. If we graph that on Desmos, we get a graph that looks like this. So it is symmetric to the y-axis. So that is an even function. And our third and final graph, if we have h of x to the 4 root x we are going to find that we end up with, let's see, there it is. End up with something that looks like this. And so in that case, it's going to be neither, because there is no symmetry. Okay? No symmetry and neither. Okay? That is it for day 2 on section 1-2.